In this short video, we're going to look at the gradient function. So what I mean by that is I want to use the process of differentiation to determine the value of a gradient, or given the value of a gradient at a particular point, what would be the equation of the tangent, and so on. So we'll take some examples. First of all, how do we do it? Well, the first step is that we find dy by dx. So we've got a function and we want to find dy by dx. The second step in the process is that we substitute the value of x into dy by dx. So into dy by dx. And the third step is that the value of dy by dx, whenever you've substituted in the value of x, is the gradient. Best way is to take an example. So we've got a function that y is equal to, say, 3x squared plus 7x minus 5, and we want to find the gradient at point 1, 5. So when x is 1, y would be 5. So let's see, 3 plus 7 is 10, 10 minus 5 is 5, yeah. Okay, so we want to find the gradient at 1, 5. So the first thing we do, dy by dx equals, we differentiate 3x squared, we get 3 times 2 x to the power of 1 plus 7. Minus 5 is a constant, goes immediately to 0. 7x just goes to 7. So that's equal to, so dy by dx equals 6x plus 7. Third step is to find the value of, second step now is to substitute in the value of x into dy by dx. So when x equals 1, dy by dx equals 6 times 1 plus 7 is equal to 13. So the gradient at 1, 5 is 13. Now we can actually use that to determine the value of, the equation of the tangent at the point 1, 5. So let's do that on another page. So the equation of the tangent to the curve. Well, how would we do that? Well, again, first of all, we find the value of the gradient, unless of course you've been given it. Okay. Now, then you would use y minus y1 equals m on x minus x1, because the tangent is a straight line. And so you find the gradient at the point x1, y1. We substitute into that general equation, and we should then get the equation of the tangent. So let's do it with this example. So y equals 3x squared plus 7x minus 5, and we want to find the equation of the tangent at 1, 5. Well, we know that from the previous work, gradient has a value of 13. So we get x1 is equal to 1, y1 equals 5. And so y minus y1 equals m on x minus x1. So y minus 5 equals 13 on x minus 1. So y minus 5 equals 13x minus 13. Take 5 across. So y equals 13x. Bring the minus 5 across, becomes plus 5. So minus 13 plus 5 is minus 8. So that is the equation of the tangent at 1, 5. So the process of working out the tangent is really, it just follows our standard straight line equation work that we've been doing. Another thing that we can look at is we want to find the points, maybe a point or points on a function or a curve where the gradient is equal to a. So say a is 10 or something like that. Depends on the type of function. If it's a quadratic function, there'll be 1 point. If it's a cubic function, there may be 2 points, and so on. So let's just take an example that I might want to work with. Let's see, find the gradient where equal to a. So yeah, we'll work with the same one. So find the point, because it's a quadratic we're working, on y equals 3x squared plus 7x minus 5, where the gradient is equal to 10. So we know that dy by dx equals 6x plus 7 from our previous work. And so what we now do is we say that the gradient is equal to dy by dx. So that's your 6x plus 7, and that's equal to 10. So 6x plus 7 equals 10. 6x equals, carry the 7 across, becomes 3. So x equals 3 over 6, or a half. So at x equals a half, y equals 3 times a half squared plus 7 times a half minus 5. So y equals 3 over 4 plus 7 over 2 minus 5 equals, what does that equal to? 17 over 4 minus 5. So minus 3/4. So point with m equals 10 is a half minus 3/4. And that's it. So in this example, what we've done is I've shown you how to calculate the gradient function. You find dy by dx. To find the value of the gradient, you substitute x into the gradient function, and then you can then similarly find the value of y at that value of x. To find the equation of the tangent, we have to establish the value of the gradient. We need to know the point that it passes through, and we use y minus y1 equals m1x minus x1, and substitute in the values of gradient, and x1 and y1 will give us the equation of the tangent. We can also find the points on a function where the gradient has a particular value. Again, we find dy by dx, we equate it to the value of the gradient and solve for x, and then substitute that value of x into the original function to get the actual point that it's located at. Thank you.